All right, hi, I'm Vishesh. I'm going to be presenting Physics 2, Lab 2 for this semester. So some important themes for this lab, we're going to be using Newton's second law that F equals ma, Newton's third law, every force has an opposite and equal reaction, and the principle of superposition of electric fields. And below you have two equations, the electric field formula and then the force due to an electric field. So the introduction for this lab, the purpose of this lab was to find how two pieces of charge tapes interact with each other and how they interact with other charged or neutral objects. And then we wanted to calculate the total charge on each piece of tape. But this lab was different than lab 1 in that we're treating the pieces of tapes as lines of charges instead of just singular point charges. And below there's a diagram for how we conducted the experiment. So a quick review of lab 1 itself. So we created two U tapes which were charge tapes, and we wanted to observe the interactions with other objects that were charged or neutral, and then also how they interacted with each other. So we would do that by holding one tape underneath the other and measuring the distance that the above tape was lifted in response to the bottom tape. And then we would sum forces in the y direction to find that the two tapes interacted and find the charge and number of extra electrons on each tape. And so some measurements that we got from lab 1 were that we had to measure the length of the tape. We got the mass of the tape calculated from a given density of tape. We had a separation distance, which we measured when the above tape floated up, and we had the gravitational force, which was due to mg of the tape. And therefore, since we had summed the y forces, we found that it was equal to 0, and there was only gravity and F electric acting on that top tape. We were able to calculate the magnitude of that F electric force because it has to be equal in magnitude to mbg. So discussion of lab 2. The main goal of this experiment is now to find the charge Q on each piece of tape, but we wanted to use a different approach. We wanted to find the electric field on the top tape point charge and on each of the point charges and multiply it by its charge to find the force. And so this model is different because we have each tape represented as a row of singular point charges. And so if you can see over here on the left side, we would take a single point charge and we would find the electric force from each of the individual bottom point charges and then find an E net for that singular point charge on the top left. And then we'd be able to find an F1 for that singular point charge as equal to that red point charge's Q times the E net, which was given by the sum of the electric fields from the below charges. And so eventually we were going to find that we needed to have all of these singular forces on each of the point charges above in red equal to an F electric net force. And so the sum of these forces on the red charges, like I said, were equal to F electric net, and that also had to be equal to F sub g, the gravitational force, since the y components are balanced. And we had to keep on trying different values for Q over here in this F1 equation until F electric net was equal to Fg. And so the results from this lab were that we had a model of point charges like we see in the pictures on the right-hand side. And the assumptions that we used were that we were ignoring air resistance on a moving object and assuming that each U-tape had about the same amount of charge and evenly distributed amount of charge along the length of the tape since they were created in the same fashion. So quick results, we had lab 1, they calculated that Q is equal to 1.78 times 10 to the negative 8th coulombs, but in lab 2 we found when we balanced the y components of forces, Q is equal to 2.853 times 10 to the negative 8th coulombs. And this was a bigger Q than the previous lab, and we noticed that this value was different. So the conclusion for this lab was that the results from this lab should be more accurate since the electric field is being calculated from a length of tapes instead of just a singular point charge. And the estimate of charge per piece of tape is larger than the estimate from lab 1 because the electric field is calculated from multiple point charges on each point charge from the above tape. So there's more of a summation going on and more of a infinite. If you think about it, if you were to cut something up into infinite amounts and then sum it all up, you're going to get a more accurate representation versus just modeling it as single point charges and singular forces. And so this leads us to using multiple force per length vectors, and when we added these all together, those little F1, F2, F3 vectors, we were able to get a larger overall F electric force, which is going to be larger than just a singular point charge creating an electric force on another charge. On the bottom, you can see the left-hand diagram from this lab versus the right-hand diagram from the previous lab. And so now if we take a look at the coding section, so over here, I have my computational model, which is shown by the F electric force on the top over here by this big arrow, which is due to the summation of all these little F sub 1, F sub 2 forces, and then we have the gravitational force down here, which is equal in magnitude. And so in the coding section, I'm just going to go over it briefly. I have my constants defined here. I have the function for creating the line of charges, some of the calculations for the top and bottom charges and the little force vectors, and then down here we just printed the results from our lab.